written like this or like this. Okay, with where it's just a matrix where all elements are 0. Okay, so all elements are 0. So for example, a 0 matrix of a 2 by 3 means we have 2 rows, 3 columns. So 2 rows, 1, 2, and 3 columns, 1, 2, 3. So all those are 0. So that's a 0 matrix. Okay, we also have an opposite, or we can call it an additive inverse. Where each element is just the opposite. So if that was positive, then it turns negative. If it was negative, then it turns positive. So for example, if I have A equals 3, 2, 1, 0, negative 1, 4. Okay, say it's that. The inverse we'd write as negative A equals, and then instead of positive 3, it would be negative 3. Instead of positive 2, negative 2. Instead of positive 1, negative 1. 0 would just be 0. Negative 1 would be positive 1. And positive 4 would be negative 4. Okay, so there's an example of the additive inverse. Okay, and when we add these together, 3 minus 3 would be 0. 2 minus 2 would be 0. 1 minus 1 would be 0. 0 plus 0 would be 0. Negative 1 plus 1 would be 0. 4 minus 4 would be 0. So we're basically just adding them together, and since 3 plus negative 3, it's just 3 minus 3, right, when we add them together. Okay, so there's a key concept here. So let's use them and do some examples here. Okay, so problem 3 is all about using identity and opposite matrix. Matrices. Anyways, not matrix, but you need 2 of them, so matrices. Okay, so A, we're going to do 1, 2, 5, negative 7. So this is a 2 by 2 plus another 2 by 2, but it's the 0 matrix of a 2 by 2. Okay, so for this, all we have to do is just add them together. So we're going to do equals, well, 1 plus 0, 5 plus 0, 2 plus 0, negative 7 plus 0. And when we add 0, it doesn't change anything. 1, 2, 5, negative 7. Okay, that's why it's called an identity. It's just like if we times something by 1, it doesn't change anything. If we add something by 0, it doesn't change anything. It's the same identity. So this is an identity matrix right here. Okay, so it's using the identity to just get what we originally started with. All right, and then let's do B, where we're going to have 2, 8, negative 3, 0, plus the opposite, negative 2, negative 8, 3, 0. Okay, so we're going to add those together. So when we add those together, it's going to equal, we're going to get 2 plus negative 2, negative 3 plus 3, 8 plus negative 8, and 0 plus 0. Okay, and I know it's plus because it shows me a plus right here. Okay, so if it doesn't tell you like what it told you up here, this matrix, the matrix minus this matrix, then it will show you by putting the matrices and putting the addition or subtraction symbol in between them. Okay, so then we just have to add those together. So 2 plus negative 2 is 0. Negative 3 plus 3 is 0. 8 plus negative 8 is 0. 0 plus 0 is 0. Okay, and that's our answer. Okay, so these are opposite matrices, this is an identity matrix. Okay? All right. And those are the basic, just adding and subtracting. It's super basic for this one. All right, so I just added these key properties of matrix addition. So pause it, write them all down, and then when you're done, play it again, and I'm going to talk about them. So A plus B. So first of all, if A, B, and C are all m by n matrices, so that just means that they're all going to be the same dimensions. So they're either all 3 by 2, or if one of them's a 4 by 8, then all the rest are 4 by 8s. Okay, it just means they're all the same dimensions, so that means we can add them together. So when we add two matrices with the same dimension, our result is another matrix with that same dimension, which we saw earlier, right? When we added these two together, they have the same dimension, and our resulting one got the same dimension. Okay, so when we add them together, they get the same dimension. When we added these two together, these are 2 by 2s, our final result was a 2 by 2. Just like this one. We added 2 by 2s together, so our final result was 2 by 2. Okay? So that's just going to work with anything, no matter how big or small they are, as long as they're the same dimension, we can add them, and then when we add them, they come out that same dimension. Commutative property is just like what we did with regular equations. We can switch the numbers around if it's addition. So if we want to do A plus B, we could have also done B plus A. So 5 plus 1 is 6, and 1 plus 5 is 6. Okay, and this one, it's just associative property, so it's regrouping them. So we can either add these two together first or these two, okay? If I have something like 1 plus 3 plus 4, 1 plus 3 plus 4. Okay, whether I add these two first or these two first, it does not matter. When we do 1 plus 3, it's 4. 4 plus 4 is 8. When we do 3 plus 4 is 7. 7 plus 1 is 8. It's not going to matter, okay? And then this one is just saying that there is a unique n by n matrix of 0, which is our 0 matrix, such that when we add 0 plus our matrix, or our matrix plus our zeros, we get A. So whether or not we took this last one, let me see if I can grab it real quick. So whether or not we took this last one here that we did, whether we switch these or not and put the zeros here and the 1, 2, 5, negative 7 here, we're still going to get the same result, okay? And that result is just going to be our A matrix, whichever matrix has the non-zeros in it. Okay, and then for every matrix, there is an opposite matrix for it. So whatever matrix we put here or whatever, we can always find an inverse matrix for it. And when we add our regular and our inverse, we're always going to end up with the 0 matrix. Okay. Alright, and then there's one more concept. It's called equal matrices. So that just means that the matrices are the same thing, they're just represented in a different way. So equal matrices means they have the same dimensions and equal corresponding elements. Okay, so for example, we have 0.25, negative 3, 1.5, and 4/5. Okay, and our other equal matrix, well, 0.25 we can also say is 1/4. Okay, negative 3 can say the same. 1.5 we can say as 3/2. Okay, 4/5 we can say as 0.8. Okay, we could go on and changing it. We could change this back to 0.25. We could change this